Hello students, how are you all? Welcome to AP Calculus. In this video, we are going to learn about the arc length in parametric equation, and we are going to discuss the 5 important questions which will really help you to understand the concept. So the first thing over here is that in the parametric equation the x and y will be given as a parameter of t, or they can be any other variable also, like suppose this x is given as a function of t and y is given as a function of t, ft and gt. So the arc length, suppose if you want to find the arc length from t goes from a to t goes from b, from a to b, that will be given by integration from a to b square root of dx over dt whole square, differentiation of x with respect to t, plus differentiation of y with respect to t whole square. With respect to t we are integrating, or we can also write the same formula as this, square root of f dash t whole square plus g dash t whole square. This is same as dx by dt or f dash t, both of them are same. So, and this is also we are integrating with respect to t. So let's start with the questions. So the question number 1 says x is given is this and y is given as this. We have to find length of arc from 0 to t. So first of all, over here is we have to find the differentiation of x and y. So let's do the dx over dt. Here we will apply the product rule. So differentiation of first function will be minus e to the power minus t, second function as it is, plus first function as it is, and differentiation of cosine t is minus sine t. Then we have to do the squaring of this also, dx by dt whole square. So that will become, this is basically, this is negative and this is negative. So when you are going to do the squaring, so it will be a square. Squaring of the first one will be e to the power minus 2t cos square t. This will be e to the power of minus 2t sin square t. Squaring means e power negative t multiplied by e power negative t. It will become e power negative 2t. A square plus b square plus 2, this is the a and this is the b. Now similarly we are going to do for dy over dt also. So it is e power minus t sin t, differentiation of first function, second as it is, plus first as it is, and differentiation of second, sin t differentiation cosine t. Now let's do the squaring of this. This is negative, this is positive, so it will be a minus b whole square. So first squaring of the first one, a square, squaring of the second, b square, and minus 2ab, minus 2, this is a and this is b. Now what we have to do? We have to do the addition of both of them. So dx by dt whole square plus dy by dt whole square. So if you are going to, let's say this is the first and let's say this is the second. So if I am going to add both of them, you can see that this part and this part will gonna cancel because this is positive and this is negative. So only we are going to get this. And here also, from when you are going to add the first two terms, you can take the e power minus 2t as common, and it will be cos square t plus sin square t. Similarly from the second one also, we can take this to common and we will be getting sin square t plus cos square t. Now cos square t plus sin square t, this will become 1. So it is e to the power negative 2t plus e to the power negative 2t. So that will become dx over dt whole square plus dy over dt whole square, that is 2 e to the power negative t. Now the length of arc will be, the parameter t is going from 0 to pi by 2. So integration from 0 to pi by 2, square root of this thing, right? Square root of this complete thing. So square root of this complete thing is 2 e to the power of minus 2t, this thing. So now if we simplify this thing first, it is 0 to pi by 2. This 2 can be taken out of the square root and when square root will be applied over here, it will become e to the power minus t only. Now this root 2 can be taken outside the integral, and this integration of this e to the power minus 2t, we can see integration of e to the power negative t is e to the power negative divided by minus 1, and the limit is going from 0 to pi by 2. This minus 1 can also be taken out of the integral sign. Now when we put the upper limit as pi by 2, it will become e to the power of minus pi by 2 minus, if you put 0, so e to the power 0 is 1. So therefore the final answer will be, if you distribute minus 1 inside, it will be root 2 and 1 minus e to the power of minus pi by 2. This is going to be the final length of the arc. This is the question we can solve without calculator. Let's see the next one. Question number 2. Here there is no trigonometric function, only this x and y is there. So first of all, let's calculate again the same thing. Dx over dt, differentiation of this will be 2 t square differentiation is 2t, so that will become 12t. So we can also find the dx over dt whole square, that will become 144 t square. Similarly, the dy over dt, do as it is. T cube differentiation is 3t square, that comes out to be 60 square. Now dy over dt whole square will be, the whole square of this will be 6 times 6 is 36, and this will be t power 4. So now the length of the arc will be integration from 1 to 4 square root of dx by dt whole square plus dy by dt whole square, this. So if we substitute inside this interval, so we'll say integration from 1 to 4 dx over dt whole square is 144 t square plus dy over dt whole square is 36 t to the power 4. Now for this one we need the calculator. If you simply put this integral in the calculator, it will directly give you the answer as 156.5247. This is the length of the curve. Okay, let's move on to the question number 3. This is written as x is equal to arc sin t and y is equal to ln of root of 1 minus t square. From 0 to 1 by 2 we have to go. So again, let's calculate the differentiation of this thing. Differentiation of arc sin t is square root of 1 minus t square, 1 upon square root of 1 minus t square. So I can say dx over dt whole square is 1 upon 1 minus t square simply. Now the dy over dt, to differentiate this thing we have to use the chain rule. First, differentiation of ln. Differentiation of ln will be 1 upon root of 1 minus t square. Then differentiation of this root of 1 minus t square, differentiation of root is 1 upon 2 root. So 1 upon 2 root of this thing. Now inside the root we have 1 minus t square. So differentiation of 1 minus t square is negative 2t. To understand the concept of the chain rule, like how I am doing it fastly, you can refer to my other videos also, which are available on my channel. Now if you simplify this thing, this 2 and 2 can get cancelled. So it will become negative t over root of 1 minus t square times root of 1 minus t square, that will simply become 1 minus t square. Now let's do the dy over dt whole square also. That will become t square over 1 minus t square whole square. Now, so length will be integration, we are going from 0 to 1 by 2, square root of dx by dt whole square is 1 upon 1 minus t square plus dy over dt whole square is t square upon 1 minus t square whole square. So So we have to simplify this. We can take the LCM over here as 1 minus t square whole square. So it will become 1 minus t square plus, that will become t square only. This is 0 to 1 by 2. Again integration going from 0 to 1 by 2. If you simplify in the numerator, you can see this t square and t square will get cancelled out. So we'll be getting 1 over 1 minus t square whole square. That's it. Now, so again if you simplify, this is 0 to 1 by 2 and it will become 1 over 1 minus t square dt. So up to here we are getting. Now we just have to integrate this thing. So here what we can do, let's take the minus outside also. So it will become minus integration from 0 to 1 by 2. If you take the minus common from the denominator, it will become t square minus 1. 1 over t square minus 1. Now to integrate this thing, either you can use the partial fraction or you can remember the direct formula for this also. The direct formula for this, whenever we are integrating dx over x square minus a square, it is 1 by 2a ln of mod x minus a over x plus a. That is the direct formula for this particular integration. The same formula you can get from the partial fraction also. So I am going to use this direct one. So here a is 1 and in place of x we have t. So it will be 1 over 2a ln of t minus 1 over t plus 1. And now the complete limit is going from 0 to 1 by 2. 1 by minus 1 by 2 can be taken outside. So we can apply, when we put 1 by 2 in this ln, so it will be ln of 1 by 2 minus 1 is minus 1 by 2, 1 by 2 plus 1 is 3 by 2, minus ln of, if you put 0, so it will be minus 1 over 1. So that will become minus 1 by 2 divided by 3 by 2, 2 cancel, it will be ln of only minus 1 by 3. Due to the absolute value, it will become simply ln of 1 by 3. And this is ln of absolute, due to the absolute value, it will become ln of 1. ln of 1 is 0. So final answer is minus 1 by 2 ln of 1 by 3. So if you simplify with the calculator, so you can say it will be 0.549. That is going to be the length of the arc for this particular one. Okay, let's move on to the next question. Question number 4. Here we have to integrate from 1 to 2 and this x and t are given. So first thing, the dx over dt is 1, differentiation with respect to t. So the dx over dt whole square, this is also going to be 1. Now let's do the dy over dt. The differentiation of this will be t power 5 differentiation is 5 t power 4 by 10 plus 1 by 6, and differentiation of this 1 by this part over here is t cube, that is minus 3 over t power 4. Now let's simplify this thing a little bit. It will become t power 4 by 2 and minus 1 over 2 t power 4. Now we have to do dy over dt whole square. So if you do the squaring of this also, it will become a square plus 4t power 8 b square, and this will be minus 2ab. So minus 2 times of a times b. So if you simplify this thing again, it will be t power 8 by 4, 1 by 4 t power 8. This 2 will get cancelled out, and t power 4 will also get cancelled out. It is simply minus 1 by 2. Now let's add both of them. So dx by dt whole square plus dy by dt whole square, if you are going to add them, it will be 1 plus t power 8 by 4, 1 upon 4 t power 8 minus 1 by 2. So this 1 minus 1 by 2 will become positive 1 by 2. So it is t power 8 by 4 And if you see that this is the same pattern we are getting just like the previous one. Here only there is a plus 1 by 2. So it will become the same thing, t power 4 by 2 whole square. If you observe this thing, this is t power 4 by 2. You can write it like this. This is a square. This is, you can write it like this, b square. And instead of 1 by 2, you can say 2 t power 4 by 2, and the second bracket is this. So you can see it is the same thing. So it is a square plus b square plus 2ab, which is a plus b whole square. So a plus b whole square. This is the dx over dt plus dy over dt whole square. It is equal to this thing. Now, so when we are doing the length, so length we have to go from 1 to 2. So integration from 1 to 2 and square root of sum of the square of this. So basically this part whole square dt. So if you simplify this thing, the square root will cancel this square, and we are going to get only integration from 1 to 2 t power 4 by 2 plus 1 upon 2 t power 4. So let's do this further. We were getting 1 to 2 integration of t power 4 by 2 plus 1 upon 2 t power 4. So this is the easy integration. T power 4 integration will be t power 5 by 5, and this 5 times 2, that becomes 10. This integration will be 1 by 2 as it is. This t power 4 you can take in the numerator. It will be t power minus 4 plus 1 divided by minus 4 plus 1. So this is the integration, and the limit is going from 1 to 2. So if you simplify this thing, this is t power minus 3, and this will also become negative 3. Negative 3 times 2 is negative 6. So basically it will become minus 1 over 6, and this t cube can be taken downwards like this. And this is the limit from 1 to 2. Now we can substitute the upper limit. When we put the upper limit as 2 over here, so 2 raised to the power of 5, that becomes 32 over 10 minus 2 power 3 is 8. 8 times 6 is 48. That is the upper limit, minus, if you put the lower limit, 1, so it will be 1 over 10 minus 1 over 6. So now if you simplify this thing, you will be getting the answer as 3.245. That is going to be the length of the arc for this. I hope you are getting this calculation. Now let us see the last question. Question number 5. X and Y are given like this. Here again the same process we have to do. Dx over dt whole square, or first let us do only the dx over dt. So when we do the dx over dt, differentiation of root t is 1 upon 2 root t. These are some shortcut method which you should remember, like root t differentiation is 1 upon 2 square root of t, like that. So therefore dx over dt whole square will be equal to 1 upon 4t. Similarly, the dy over dt, this differentiation is quite easier. 3t differentiation is going to be 3 only. Differentiation of 1 is 0. So dy over dt whole square is equal to 9. So therefore length of the arc will be from 0 to 1 integration dx over dt whole square, which is 1 upon 4t, plus dy over dt whole square, which is 9. Now to do integration for this one, this is a setup, integral we have set up. Here you can use the calculator. This is a calculator based question. So when you will set up this integral into calculator, it will give you the answer as 3.2490. This is going to be the length of the arc for this. So I hope you have understood these 5 questions. These are the ways of solving the question based upon this. This was the first question number 1. This was a non-calculator one. Then this is second question. Then third one, fourth and fifth. So now for your practice, I have given you two questions. So whatever you have learned in these 5 questions, now try to apply the same concept over here. Find the length of the arc in these 2 questions, and these are the answers. And if you want the solution of these 2 questions, you can message me on this particular WhatsApp number. I'll be happy to help you out. So if you have any other doubt related to the AP calculus, please send your doubt over this particular mail or over this particular WhatsApp number. Thank you for watching.